record.
Recording in progress.
Wow. All right. Hi, everyone. Today we are talking about missing data in the general linear model. Up until now, we've sort of ignored the possibility that your data might be anything less than pristine. We haven't completely ignored it. We've dealt with it a little bit, but still, we'll talk a little bit more about what happens if you have data that are missing. What I'd like to know first, before I move on to this next slide, is can you all give me a thumbs up if you have ever had to analyze data and realize that some data are missing in the data sets that you're working with, either for this class or any other ones? Or, no, that's never been a problem for me. All right. Yeah, so everybody has seen this issue. So then the first little bit of this is going to be me sort of explaining what missing data is. And you all sort of know what that is, so I'll go through this pretty quickly. We expect there will be data there, but there's not data there. How's that? Ha ha ha. Where does it come from? Maybe, I know a lot of you do survey-based research. So in survey-based items, something you sent out through Qualtrics, that could be just people skipping items. Maybe you have kids who are absent from school, and so you don't get to pick up their data on the day that you're collecting it in their classrooms. Maybe someone didn't understand your question, and so therefore they're skipping it because they don't know what's happening. Or maybe, I don't know, your school's all shut down because there was a global pandemic. That might be a reason data are missing. Now, what we're going to talk about today and what a lot of your readings were about are the missing data mechanism. So it's determining why the data are missing. So before you can decide how you want to handle your missing data, what you want to do about the fact that the data are missing, you have to decide or determine how data, or what is the reason that the data are missing. So what statisticians have done is they have invented the three worst definitional terms on the planet for categorizing missing data. They are just terribly confusing terms, but I'm going to try to disentangle them for you and tell you why you should care. All right, so we have three terms. They are missing not at random, missing at random, and missing completely at random. Okay, so let me tell you what data missing not at random means. So if you have data that are missing not at random, they're missing because of what the response would have been. So as an example, if you're giving a school climate survey to a bunch of teachers, and you have teachers who are experiencing a really negative school climate, maybe their principals are super controlling or all of the teachers are mean, they may be less likely to fill out that school climate survey because they are experiencing such a terrible school climate. That's an example in which the data are missing because of how they would have responded on the item. If you'd rather think about kids, I have another example for kids down here. So if you have kids who are having more conflict with their teacher, they might be less likely to respond to questions about conflict with the teacher. Maybe you ask them about conflict with the teacher and they just sort of shut down and don't respond. So that's another instance where, because of the thing you're trying to measure, they are not responding to the questions about it. So in those instances, the data are considered missing not at random. Now the next one is defined as missing at random. Missing at random is when the data are missing, but that missingness, the fact that it's missing, is related to something else that you have measured. So it can be explained by some other thing that you have measured in your data or in your study. So here's an example I have, which is maybe you have newer teachers and they may be less likely to respond to your survey just sort of generally. Newer teachers tend to be more overwhelmed. They just can't handle doing one more thing. So they may not answer your survey. So we can predict whether the data are missing based on how long they have been a teacher. So that means the data are missing, but they're not missing because of how they would have responded necessarily. They're missing because of the fact that they're a newer teacher. Here's another example that happens a lot in longitudinal educational research. When we have kids who come from lower socioeconomic status backgrounds, we're more likely to lose them over time because there's more mobility in a population of lower socioeconomic status kids. So if we know that these kids are more likely to attrit from our study over time, we can predict that attrition from their socioeconomic status at the baseline. In this case, it's not necessarily how they would have responded or how they would have done on our items if we had given them to them. It's because of this other third variable. So when you can predict why the data are missing, then the data are missing at random. And now we come to the third category, which is the missing completely at random, which I just have to imagine statisticians sitting in a room and sort of going, well, we already have missing at random defined. What should we call this one? And they sort of go, completely at random? Yeah, all right, that's good. We'll make it missing completely at random. Okay, the data are missing, and the reason the data are missing is truly for a random reason. So here are two examples. The first one is you've set your Qualtrics to randomly not ask question 3 to half of your people. That would be probably an accident, maybe an accident. That is a completely at random reason. If it's really dropping a random subset of your participants, then it's really random. Another example is that you purposefully randomly assign a proportion of your sample to get specific items or not get specific items or tests. And that is called planned missing data, and it is super cool and one of my favorite things to talk about and something that I do research in. So you can deliberately decide to make all of your surveys even shorter by randomly assigning people to give specific items to. In this case, you have data that are missing completely at random, and you can use the techniques that I'll describe in this lecture today and that are in the papers that you have to read and recover all of your estimates just fine. I'll explain that too in just a second. Okay, so we have 3 things. Missing at random, missing completely at random, missing not at random. Again, 3 of the most confusing definitions on the planet. But really, these missing data distinctions are very theoretical. And I like to make this parallel here to early days of COVID, because in the very, very early days of COVID, one of the very first things that happened, when I heard this story, this is the first thing I thought of. So one of the first things that happened when they were writing up original reports of COVID cases back in January 2020 or December 2019 is there were early cases where scientists were describing transmission happening asymptomatically, so that there was an asymptomatic person and someone got sick after contact with an asymptomatic person. And that study was held up in peer review for months and months because the scientists couldn't agree whether they were pre-symptomatic or asymptomatic. Which the difference between pre-symptomatic and asymptomatic is massive when you think about implications for how viruses work and what does that mean? Do we have a typhoid Mary situation or do we just have, somebody who's about to get sick? And those are 2 very different things in terms of how viruses work, but in terms of whether I should go to the store today, they are the same. So I like to draw that parallel because I think that the distinction between these 3 things is a little bit overplayed and is not quite as crucial as it may feel like. So don't feel like I'm not sure what kind of missing data I have, therefore I'm stuck here and I can't do anything about it. They're pretty theoretical. They're really just for those of us who want to think about this stuff for fun. We exist. Okay, because here's the thing. Post hoc, you can never prove that one of these is the case. There is no statistical test that you can run to say, my data are definitely missing completely at random, or my data are missing not at random. You can't, there's no test that exists because the thing about data being missing is that they are missing. So you can't actually test what's going on with them. So you, as the researcher, just to parallel back to what we did at the very beginning of the semester, these data don't know where they come from. The missing data also don't know where they come from. And so you have the burden as the researcher. It's your burden to argue about the missingness mechanism that is most likely in your data. So you have to take the evidence that you have, and I'll show you some tests you can run to gather some evidence, but ultimately it's up to you to say, this is what I see and this is what I think it means for my data. Okay. So why does that argument matter? Why would I ever want to make that argument about what should or should not be missing? It's because each of these three types of missingness, even though they're really purely theoretical, just like our COVID distinction, they carry with it slightly different assumptions about how valid your inferences are and about to whom your results generalize. But really, these are just logic, and so I'll walk you through them. And I think that you'll make that connection pretty easily because it's sort of a logic-based problem, not a statistics or a math problem. It's just a logic problem. So, for example, if you delete anyone who has a missing item, you can only generalize to people who gave you complete cases. If you're giving a 100-item survey to people and 50 people don't finish your survey and you delete them, then you are not generalizing to the population. You're generalizing to a population of people who are willing to sit for your 100-item survey. Or in our example about kids who are showing up to school, you can only generalize to kids who are showing up at school. So I'm going to describe those consequences a little bit more deeply next. So if you have data that are missing not at random, you're kind of out of luck. If you're pretty sure that the reason why these data are missing is because of how people would have responded on these items, it doesn't matter what you do. I'm going to tell you how we're going to treat these missing data in the future, but any way that you treat these missing data, you're going to be wrong. Because we don't know what their answers would have been, but we think that the missingness is related. So all you can do in this case, if you're pretty sure that your data are missing not at random, or you think they might be, all you can do is write about it in your conclusion section. You can describe what you see, you could describe how much data are missing, and then you can describe your results, and then you have to say, these results only generalize to those people to whom I have fit these data, and we think that there may be some people who didn't answer, and that may have affected our results. That's all you can do. Now, if your data are missing at random, you're going to be just fine. Because missing at random means that the missingness is related to something that you measured. And so if you figure out what the missingness is related to, then you can control for all of those things, just like we've been doing with controlling for other things within our statistical models. We just plop those variables into our statistical models that are related to the missingness, and then we can recover all of our estimates just fine, which is honestly pretty amazing. And lastly, if you are lucky enough to have data that are missing completely at random, this is your best case scenario. There are so many ways to handle the missingness. It really doesn't matter what you do, you're going to be just fine. Because the missingness is completely random, you can even delete any incomplete cases and you'll be just fine. You can still generalize to the population because you have that people are missing for a completely random reason. Now, the only downside is you would change your total sample size, which isn't great for statistical power, but if your sample is supposed to generalize to a specific population and your data are missing completely at random, then you can still do that same generalization. Now, the problem is, of course, that you can't actually test to see if your data are missing completely at random. I think I actually explained that here on the next slide. So as a quick review here, you have 3 possible ways that your data can be missing. These are the short versions of those that people use to describe them. You can never prove whether your data are missing completely at random. That's the good one, MCAR. And, just so you know, they almost certainly are not, unless you have done it on purpose, or unless you find out post hoc that somehow you accidentally lost some things. If you have your, I don't know, all of your surveys sitting in a stack and they're in a completely random order, and then somebody comes by and grabs the top 20 of them and throws them away and you don't find out till later, those are missing completely at random. So it's a really random scenarios where that might come up. But generally, you almost will never have data that are missing completely at random. But most of the time, your data will be missing at random. You might have data that are missing not at random. That's the bad one. But again, you can never prove that you don't. You can never prove that you do either. Yeah. Hannah said the dog ate my samples. Yep. Although not if they all came from the same day at the same school or something like that. If you think you might have data that are missing not at random, which is the bad one, you can't ever prove that you do or do not. You can describe what you have and you can make an argument about what is there, and you can discuss it in your discussion section. That's all you can do when your data are missing not at random. What you can test, the only thing you can test, is whether your data are missing at random. And I'll show you how we do that. Okay, wait, before I show you how we test about data missing at random, do you feel like you have at least a fuzzy understanding about missingness mechanisms, the 3 different things? Kind of got it? Don't got it? Are there points I can help clarify about the distinction between the 3?
Quick clarification, because I don't think I wrote it down. And you went through this, click through the slides, but the one that you can test for, that's a missing at random, not the missing completely at random, right?
Correct.
But the one that you can control for in the analysis is the missing completely at random.
Nope, it's still missing at random. Whoops.
Okay, so you can control for missing at random, not completely at random.
Right. Missing completely at random, nothing is related to the missingness because it's random. So there's nothing you could control for to predict the missingness because it's a completely random process.
So that's the one that's the best case scenario then.
Yes.
Okay.
Best case scenario and almost impossible. It's like pipe dream unless you set your data that way up on purpose. So almost certainly anybody, all of you who said, yes, I've analyzed data and my data are missing, they are almost certainly missing at random. They may also be missing not at random, but mostly they're going to be missing at random, which means the missingness is related to something else. It's just whether you've measured the thing that it's related to. All right, how do we test it? That's a lot of text on this slide, but I'm going to do it a couple of times. First, how we're going to test whether the data are missing at random is we're going to think about a variable. So you all have just told me you've thought about instances in analyses you've run. So think about a variable right now that you have worked with where you've seen data that are missing. Just like jot it down on the side of your paper over there. Or you can put it in the chat. Even better. And once you've identified a variable, the next thing that you'll do is within the data, you would look at how much data is missing on that variable. I won't make you do that right now because I'll walk you through how that works in a minute. And then next is to sit and theorize for a bit. So next is to create a list of the variables that you have measured that you think might be related to whether or not you have data on this person on this variable. So when I talked about school climate, my idea was could be that people who have terrible school climates are feeling really burned out and overwhelmed and might be less likely to complete my survey. Or it might be I could imagine that first year teachers, earlier teachers might not want to fill out my survey. So that's another thing that I would want to write down in my list. I might theorize that my special education teachers might have felt like this survey didn't really apply to them and maybe they didn't want to fill it out. So I'm going to check and see if my the type of job that my teachers are in is related to whether they filled out my survey. So there's just so sit and theorize and think about what else have you measured that might be related to whether or not they completed that item or subtest. Then we're going to create a new variable. Now, stick with me. This feels a little weird, but what you do is you create a variable and this new variable indicates whether there's data missing or not. So if my variable is school climate survey and I have 200 people and 25 of them didn't finish it, I'm going to have a new variable called something like didn't complete my climate survey. That's a terrible variable name. Never name variables that long. Called climate survey missing. And it's going to be a 1 if it's missing and a 0 if it's not missing. So I'll have 25 ones and the rest of them will be zeros. So now I have a new variable. Is the data missing or not? And we just learned last week about logistic regression. So what we do next is then we're going to predict that brand new variable about whether the data are missing from that list of variables we created in step 1.2. So I'm thinking maybe my special education teachers aren't going to complete it. I'm going to look at a logistic regression predicting is this data missing from what type of teacher this is. And if it's statistically significant, my groups are statistically significantly different from 0 here, then that is going to tell me that this is related. Now I know my data are missing at random because I am predicting whether things are missing. So you're using the same method that you've already learned about logistic regression to test this additional way of looking at your data. So next, you're going to repeat that step until you've identified everything that might be related to the missingness on your key variable. You've now demonstrated that these data are missing at random, and you just repeat it for every predictor or every outcome that you have or plan to use in your analysis. And you would do this separately for every analysis you plan to run, because all of missing data, understanding missing data is specific to an analysis, not a data set. It's specific to an analysis that you plan to run. So sometimes we would call these related variables, the variables that we found to be statistically significantly related to the missingness here in step 3. Those are called auxiliary variables in the missing data lingo. So you use those auxiliary variables to get a better estimate of the parameters in your GLM, which I'll show you what happens in step 6 later. But right now I want to make sure that you're understanding this steps 1 through 5 about how to create this new variable and how to check whether things are related to it. So I want to walk through that real quick. What I'm going to do is, do you remember this data set we have called grad pubs? This is the real data set about graduate students and how many publications they have. And so there's this confusingly named variable, which is A11_A_2, which is the number of refereed articles that they have as a graduate student. And the amount of missing is I have 763 missing cases out of 5,000 possible cases. So I have some missing data. So let's think about why might these data be missing? So I want you all to think about this, and then if you think of something, shout it out. I'm going to put a timer up. Can you see this if I make it like... Come here. I'm going to put a timer up. Aw. Why might number of publications be missing in this data set? Drop something in the chat or shout it out sometime before these 5 minutes are up, and I will pop it in here.
They're newer, they might not have any yet, so they might not want to tell you that they don't have any.
It also might have been too long ago that they don't remember.
Adriana put in the chat that if she has a ton, she might be too lazy to count them.
Living the dream. Some of those economics folks, I think I filtered out anybody who had more than 100. You can also think about what might be related to the fact that it's missing. Not related to how many they have, but related to whether or not they reported it. Yeah, I think that you're right. Might not have any yet, new. They might be embarrassed that they don't have any yet, so they might skip it.
I guess there's also an argument to be made, like if I'm in the middle of dissertating, I'm probably too busy to take time to fill out the survey, so I would skip that question. Which is the exact opposite of the new argument.
What about differences in, what about people who are too busy for other reasons?
Karen?
Yeah, I definitely led you, but I'll take it. Parents might, I mean, this could be related to this. If you're a parent, maybe you have fewer publications, and then maybe because you have fewer publications, you're more embarrassed and don't fill it out. So we've got a whole chain of logic. Let's see, I've only got 1 more minute, but I'll pull this. Whoops. Can you see this? It's kind of small.
Adriana put in the chat departments. Some might care more than others.
Yeah, some might care more than others. So we've got the, department. If a department cares more about publication than others, then, sorry, I'll tell you why I laughed in a second. It was a private message. So if some departments care more than others, they may be more likely to respond to this. I mean, I know that in, say, the education, an English department, they are more concerned with books and wouldn't maybe ever publish a peer-reviewed paper, and so might just skip over that question because they think it doesn't apply to them. So I like that idea of departments might really matter. Nobody else can hear it, but I heard it. It went off. Hoda said, maybe they manipulated the data and they're afraid of reporting it. Hopefully not. Okay, so now we've got a list. So let's think about this first one. Let's think about this first one where we can see it. The person might be new. They might not have any yet. Wait. This is two different ones. If the person is new, what kind of variable is that? Do we have a variable like that in this data? Well, you don't know if we have a variable like that in this data set, but how might it be conceptualized?
Year in program.
Yeah, good. Year in program, which I think is also maybe not this one. How would we do this one? Might have been too long ago.
Years since publication.
Yeah, since publication or program. Do you think that, I'm not sure who said that. Sarah, was that you? Do you think this captures
Yes.
that idea? Now, what about these two? They might not have any yet. Might be embarrassed. I know we don't have any information on how they felt, their affect while taking this survey, so we won't be able to measure this one, although this is a really good, interesting thing you can put in your discussion. What about not have any yet? What is our only evidence? What would be our evidence of that?
Do you have anywhere where you like have them list their publications?
We don't, but you're onto something here, is that it's about how many publications you have,
Mm-hmm.
which is a very specific type of missing data mechanism. When we have right here, we're thinking that because of what their response would have been, they might have skipped this item. Do you remember which one that's called?
It's the first one. Missing not at random.
It's missing not at random. That's right. I'm going to just say the bad one. So this right here, this is totally possible. If I don't have any yet and I'm feeling embarrassed and I don't want to respond, totally possible that I don't fill this question out, in which case this is a really important point to put in your discussion of your paper. We're already writing our discussion and we haven't even analyzed the data yet. How cool is that? Okay, we did this one. What about this one? I have a lot, so it might be too lazy to count them all. Somebody besides Kimiko needs to respond on this one. I can roll a die again if you want. Years since they got PhD. Well, in our previous work, we have determined that years from PhD is related to how many publications you have. That's true. But in this case, we've got, if we have that here, year since publication or program, we can say or PhD. Good
I have a
typing.
question.
Yeah.
Is this data set on people who have graduated, or is this data set on people who are currently in a doctoral program?
I believe this is people who are currently in or have recently graduated.
Got it. Thank you.
I guess I have a follow-up question. Is it possible they've bounced to another degree afterwards?
Totally possible. Yeah. Totally possible.
They
Does
decided
that-
they hated English and they're going marine biology and threw it all in the bin, and so what they did before doesn't count.
Or maybe it still counts, but it counts differently because you have lots of book chapters that are books that you wrote as an English person, and now you're overdoing marine biology and all they care about is papers.
Yep.
All right, I'm going to bring us back here, which is I'm too lazy to count them all. That means I have a lot of publications. How would we know if somebody who has a lot of publications is missing on this item?
Wouldn't that also be missing not at random?
Yeah, it would. That would also be missing not at random. Oh, look at that. That would also be missing not at random because the reason why we think it might be missing is the response that we would get on this item. And so we can't ever test it, in which case that's another point we have in our discussion. People at the extremes might be underrepresented here. Okay, let's talk about this one. If I'm dissertating, I might skip this question because I'm too busy. We can look and see, maybe we have a question about stage dissertation. Like, are you dissertating right now? And then, are you a parent? We definitely have a variable. We created this variable in a previous class. And then which department you're in, we have that variable too, right? It's, what were there? Were like 3 categories or something. Human behavioral. Okay, something like that. So in reality, you would spend a lot of time looking through your variables before you've touched them. You'd think about what might be related, and you would sit together with hopefully another colleague and sort of go through things and make sure that you've captured them all. And then you would go into the testing phase. So what I want to do next is I'll show you how we create this new variable and how we predict it. And I'm going to stick with this one question about whether or not you're a parent, just because I know right where it is and I know what it is because we've used it before. All these other ones are very interesting and would be really exciting for you to do for the homework assignment that will be due next week. And otherwise, we'll stick with just this parents question. All right, let's do that. So here we go. Within this data set, we have, I wrote down the variable name here. I'm going to get our syntax file ready. And the first step, if you remember here, is making a new variable, which is if it's missing on our key variable or not. So let me get the variable name. A11 underscore A underscore 2. Missing, what did I say? Missing pubs. I called it miss pubs. Okay, so the first thing I'm going to do is I'm going to create a new variable called missing pubs, and I'm going to set it equal to 9. And I'm doing that because I'm going to check my own math here in a minute. So next, I'm going to do this. If miss pubs, no, if A11 underscore A underscore 2, Jessica, if missing A11 underscore A underscore 2, miss pubs equals 1. So that's if it's missing, make this variable equal to 1. Actually, I think else works. Let's find out if this code works. I don't remember if this is how you use else anymore. I've been programming in another language for too long. Let's see. So I ran that, and my output is hiding. Well, this is not good. Look at that. None of it worked at all. It does not like my else expression, so I'm going to try that again. So I'm going to say if not missing equals 0. See if that works. Hey, look at that. Dun dun dun. That works. So I'll copy that and paste that syntax in there for you. So here we go. Now what we've done is created a new variable, and this is called misspubs, and that is equal to 0 if it's not missing and 1 if it is missing. So we're missing for 762 people. Make sense? All right, so now we're going to use the logistic regression skills we learned last week. And I will paste that in here. I don't remember the syntax anymore, so I'm going to do this. I think we get our parameters automatically. And now, so I have, are you missing publications or not? And then I'm going to enter my predictor, which is called, this variable we just made has kids. We made a couple of weeks ago. Oh, look at our, this is, remember, we have block 0 first. Block 0 tells us nothing because that's the grand mean model. We're guessing the mean for everyone. So we're going to skip right past that and get to block 1. Block 1 looks like our Nagelkirky R squared is 0. Our Cox and Snell R squared is 0. We are not predicting anything. Our missing publications, we're still predicting that nobody's missing. Has kids is not a statistically significant predictor of whether somebody's missing. So this is not related to our missingness. And now we know that we don't need to include this as a control variable moving forward. If this was statistically significant, then we'd move on through this step. So we did this, we created the new variable, and then we predicted it. So it's not has kids. That didn't help us. And then you would repeat that process for the rest of your variables to figure out what's related to the missingness or not. Once that's done, oh look, I forgot I ran this already. Once that's done, then you can move on to steps through the rest of these steps, repeating them, and then having your final set of variables. Okay, we're going to pause there. So let me know if this process here makes sense. The creation, how about the creation of a new variable? Good. Predicting it using logistic regression.
Can you show us the syntax again?
I sure can. And you know what? I'll put this in the whatchamacallit for today. Module for today. No, A11 underscore A underscore 2 is missing. Okay, and this is the next step, which is the running actually, you know what? This is also in the handout that I've given you. Come here. Which is now opening. So this is a handout that I've also uploaded there, which is also part of the missing data decision tree. And you should be able to follow it. It gives you all of those, all of the codes to follow through and do exactly what I'm talking about. And I'll come back to this later on as we get through the next steps. Okay. Did I see, Duani, did you have your hand up?
Yes. Sorry. I had a question was earlier when you said that that was not significant and you said, okay, so now you can use another variable. So like last time, how you said like we did it with 2 or 3 variables. Do we just run it together and say, hey, this didn't work, this worked? Like, you know, is that a good idea or no?
You mean is in a multiple logistic regression or a multiple regression analysis?
Yes. Like,
No, in this case, it makes more sense to do them separately. But you can put them all together. Actually, I don't know. It doesn't really matter. You could do it either way. Probably be
But
faster to do them all at once.
yeah, because I feel like doing one at a time, you're running too many things, and then you have to always keep a tab, right? That this is for this is for this. Instead, you have one table which has all of them together. Like, is it a good idea or no? Like, I don't
Yeah,
know.
I think that's a fine idea. I
Okay.
wonder if I suggest that specifically here. No, I think I just go through each one separately. So I actually am not sure. That's a really good question about what the schools of thought are in terms of whether it's better to do one at a time or to do multiple at a time. And I actually don't think that our missing data decision tree speaks to that. So, but I will double check on that while we're on break here in a minute.
Okay. Yeah.
That's a good question. Okay, we'll be back in a minute.